Hey everybody, how's it going? Here we have an A1466 MacBook Air that's not powering on. Let's see if we can open this thing and figure out what's wrong with it. So now what we do with all of these MacBooks is we unplug the battery and then we plug the charger in. Because if we unplug the battery and then plug the charger in, it's going to show us on the screen how much power the charger is using. And that's going to be a useful number that helps me figure out what's wrong with the computer. Here it looks like it's taking 6 milliamps, a number I'm not used to. That typically means that my charger is not making contact with the machine. Let's see if that's the case though. I'm going to put this in voltage mode and see if anything from here is reaching into the machine. Actually, I can tell before I even do that it's not. And I'll show you how I know that. I'm going to open up a schematic and a board view for the 820-00165. By the way, for those of you who always ask me, how do you know where the board number is? Well, you need to know the number of the board to know where the board number is, because the board number is written in different spaces on every model board. So this is really an issue of eyesight, because if you're unable to see where the board number is, you're probably in the wrong business. On this board, the reason I know that it's an 820-00165 is because the number is written right over here where it's clearly visible. See? 820-00165. Right there. So if you're not able to see that, you might just be in the wrong industry. But let's get back to trying to figure out what's wrong with this board. Now, if you look at it, you'll see that there is a teeny tiny bit of corrosion in the corner. Right over here. And we're going to look at that corrosion in the microscope. And I'm going to show you why it is that this machine is only taking 6 milliamps. And also, just to note, if you've been watching regularly, you know that I try to troubleshoot the board and figure out what's wrong with the board by taking a look at how many milliamps it's taking on the charger when I plug it in. So now, if you've been a regular viewer, you know I'm going to add to my list that 6 milliamps is going to mean a problem with the input of the PP3V42 circuit. So let's take a look at that area and see if you can tell me what you see going on. There's corrosion over there, but there's one particular piece of corrosion that's going to be the corrosion that matters. And it's going to be the corrosion that stops power from flowing through to anything on this MacBook. And it's going to be this little diode right over here. I'm simply going to brush a little bit around that diode, like so. And then I'm going to take a little Q-tip along that diode, like this. And there's a good chance that this computer is now going to turn on. Let me show you why in the schematic while I wait for my alcohol to dry. So I'm going to open up a schematic and a board view to an 820-00165 board. And you'll all be able to follow along with me. We're going to find that chip, the PP3V42_G3 hot creator, U7090, and we're going to move the PDF over to it. So, this is the power supply for the 3.42 volt rail. That's required to power the system management controller. The system management controller is powered by 3.42 volts. That's going to be what turns the charger on. That's going to be what allows the ISL6259 that creates PP-G3 hot, the main power off of the system, to work. Nothing in the system can work if 3.42 volts doesn't work. Now, it has an input over here. Remember, this is going to have to be powered on battery or charger. It's the only rail in the system that needs to be powered by the battery or the charger, which means that it's going to have multiple inputs. So when you take a look over here, this is in, but that input can be powered by either PP-G3 hot or PP18V5 DC-in. Wow! So you have two different ways of powering it. PP-G3 hot, which is the battery, or 18 volts, which is going to be from the charger. This over here is going to be the charge port, J7000. Now you have a diode over here. The reason is that PP-G3 hot is a power rail that comes from the battery, or if the battery is dead or not plugged in, it's created by the ISL6259 chip by the charger. You don't want 18 volts going to your battery simply because they're tied to the same input. So you have a diode over here that presents the 18 volts from the charger from going into PP-G3 hot. Now, when it comes to the charger, the charger is not hooked up directly to the input of the PP3V42 circuit. The charger is hooked up to to something else. If you take a look over here, the charger goes to a transistor, Q7010. Now, this here is what's called a P-channel MOSFET. If you're unsure what a P-channel versus an N-channel is, I'll explain. And if you're unsure of how to tell a P-channel from an N-channel, I would suggest that you simply Google the name of the transistor. Not this name, not Q7010, SI5419. Q7010 doesn't actually mean anything. So imagine if I said, Dad, do you know where Mom is? Dad would know who I'm talking about because I'm talking about my mother, and that has a relationship to him because I'm his son. Whereas if I go into a hotel lobby and I ask the attendant, have you seen my mother? That doesn't mean anything to him. He doesn't know who Mom is. He needs to know, are you looking for Donna Pomponio? Then he'll know that I was looking for my mother. Over here, the same principle applies. Q7010 only means something to this particular Apple motherboard, but the actual name of the component is SI5419DU. And if you Google that, you'll see that it is a P-channel MOSFET. The reason it's important to know a P-channel MOSFET from an N-channel MOSFET is that a P-channel MOSFET is going to open when the voltage in the gate is lower than the voltage in the source, whereas an N-channel MOSFET is going to open when the voltage in the gate is equal to or higher than the source. Knowing what the expected behavior is of the chip is going to allow you to understand if there's a malfunction with it. So, this is a P-channel, which means that this is not going to allow any power to go from the source to the drain unless the voltage in the gate is lower. Think of this like a light switch. Source to drain is like the in and out of a light switch, and the gate is kind of like the position of the switch, whether it's on or off. If you have voltage at the gate that's lower than the source, the light switch turns on. If you have voltage at the gate that's equal to or higher than the source, the light switch turns off. So, knowing that this is only going to open when the voltage in the gate is lower than the source, let's take a look and see how this is set up. So it looks like we have a resistor over here between the source and the gate. These resistors are not going to drop voltage. They're simply going to drop the amount of current that can flow through, which means that the 18 volts from the source is always going to be present on the gate, meaning this will never open, unless we give the gate a path to ground. If we give the gate a path to ground, which is what we do over here, see this, D7012, that means that some of that voltage is going to go to ground, meaning that we're not going to have 18 volts in the gate. This diode to ground is not going to affect the voltage at the source because you have a 100 kilo ohm resistor isolating the current flow between the source and ground. However, it will affect what's going on at the gate. So you'll see that the diode is the path to ground. And if you look over here on the actual board view, you'll see that D7012 is going to be that very component that we saw having the most corrosion on it. Right here, D7012. Now we were able to clean that diode with a Q-tip. And since we've cleaned the diode with a Q-tip, it's probably going to work again. We're just going to do a little bit more over here. And we'll touch this up with some solder at the end, of course. We're not going to leave a board like this with little corroded stuff stuck on it. When a customer trusted us over the Apple Store with their machine, their data, and their money. But just for testing purposes, I'm kind of curious to see if the Q-tip is able to solve the problem that the Genius wasn't. Just get the alcohol to flow away. Now, we're going to plug our charger back in and see if this works. I'm going to turn on the power supply software so you could see it on the screen. And we plug it in and we get a green light and 500 milliamps of usage from the charger, as well as a fan spin, meaning that this machine now works. Apple, you quoted this woman $750. $750. I fixed this with a Q-tip. what we're going to do is we're going to put the proper amount of flux. And this is going to help fix the integrity of those solder joints. Okay. Now, what I'm going to do with that diode, just to make sure that I get a good job done on it, is I'm going to tap it. What this is going to do is it's going to move the solder around in the little ball that it's in a little solder ball. And it means that the corrosion is probably going to get bounced out of it, which is exactly what I want. Which means that not only is it going to be, a kind of half their connection, but it's going to be as good as it was prior to the liquid damage. And that one resistor that looks like it could be a little bit nicer, we're going to file that with my Paco 2032 tip. And my T30KN tip on the 2032 iron. See that? We're just going to redo that joint like that, scrape a little so that any of the corrosion leaves, and do the same thing for the other side of that resistor. And it'll be like it was never corroded. And anywhere I see that kind of reddish, rust-looking junk, we're going to take this tip, which is shaped perfectly for the sides of these QFN chips, and file. Back and forth with the flux there, and just file. Now, if you can see that it looks like there's corrosion under it, then you take the chip off. But if there's not, this will do the job. And any of these probe points that look like they're a little rusted, where the resistor is going to be communicating with the chip, or sending voltage to the chip, scrape, scrape, scrape. And there we go. This machine is likely going to be good until the end of time, until the user decides that they're going to spill more liquid into it. Remember, your MacBook is not thirsty. Now we're going to see if this thing gives us a question mark folder on the screen once it turns on. As you can see, we get a question mark folder on the screen, meaning that our repair is complete. The only thing we have to do at this point is ultrasonically clean the motherboard to get rid of any corrosion that may be hiding under the chips. We have a nice Crest P1200H45 over there. It's a nice piece of kit. It's going to get a nice sweep frequency ultrasonic. It's going to get under every single chip and remove all the junk from the board. And once that's done, this will work lovely again. And it'll be ready to go back to a happy customer. That's it for today, and as always, I hope you learned something. See you in the next video.